Today we're going to go on a field tour. So we're going to take the opportunity to look at cover crop work that's been done from central Oregon across southern Idaho and down into Utah. And I'm Steve Hines. I'm with University of Idaho Extension in Jerome County. We really want to thank Western SARE for providing the grant funds to make this opportunity possible. All right, so on our final presentation today, I'd like to introduce Jacob Hadfield and Michael Pace. They currently work with Utah State University Extension in Cache and Box Elder counties, working with alfalfa, corn, small grain, and safflower crops. They received a multi-year grant to research cover crops in Utah due to the lack of information on growing them in the Intermountain region. And they're going to be sharing first-year results from the 2020 growing season. Welcome.
Me and Mike Pace have been working on this project it's been a year now. They actually had some plots in the previous year. But this project is kind of looking at different cover crop mixes, different strategies to use cover crops in Utah. So I'm going to turn the time over to Mike to go ahead and introduce us into the project, and then I'll be going into a little bit more of the data involved with it. So
the reason why we started working at this is there's been, for the last 5 or 6 years, there's been a lot of soil health workshops and that around Utah. A lot of the presenters that they bring in are from the Midwest, and they give their information and that, but it's kind of irrelevant to here in Utah and in the Intermountain West. And so that's where we kind of started looking at this. And it's a collaboration between field staff and our specialists on campus. And so we have 3 different locations in Utah, one kind of in central Utah, which is San Pete, and then Davis and Cache counties. And I'll tell you a little bit more about those areas here in just a second. And within those, we have some warm season and cool season. We have 5 different plots that we have in each of the warm season and cool season. And of course, we've got replicated plots so we can get the statistical analysis and that on them. We try to shoot for that 40-pound seeding rate, depending on what we're using. And then, as Jake kind of mentioned, most of our stuff, we're looking at conventional tillage in that, not a lot of no-till right now with these crops. So in Ephraim is kind of our high elevation area. We have a kind of an average growing season of about 120 days there. And on the left of that screen right there is kind of where those plots were established. And again, it was not probably a lot of activity in that soil right before we came in and established those plots. Kaysville, this is kind of our lower elevation, high precip area, longest growing season of about 172 days. This area that we came into has been has never had anything grown in it for about the last 15, 20 years. And so when we came in here, we had to do a lot of weed control in that area before we came in and established those plots. And so when you look at the data in that, we applied no fertilizer to this plot right here, just breaking it out of that, sod right there. And this is our last location. This is where most of our information that we're going to present today, because of the time limitation that we have, is in Cache County. Shortest growing season of the 3 at about 110 days, and about an 18-inch precip zone right there. And again, you can see this is a research farm. There's been lots of different projects there. Tillage is our conventional tillage operation that done on these. And this plot actually received some fertilizer, some nitrogen prior to us establishing our plots in here. And I think you'll see the difference in that when we start looking at the yield and the quality on these plots. We tried to establish our plots using something that a farmer would. So here you can see a Great Plains drill. This is, again, our Lewiston planting that we did. This is on the 14th of May. So it was just a little bit before our last spring frost for that area. And you can see several of them had coats and that on. It was kind of a cool day for planting, but it was beautiful because we were able to get it in. And then it was a rain or snowstorm. I can't remember which. May have been both right before, after we got done planting and that. So perfect timing for getting those in and getting some moisture on them to bring those cover crops up. On our mixes, so we're going to talk about our warm season mixes first. In talking with our specialists in that, one of the things we wanted to do was to, not throw a bunch of different mixes in that out there, but we wanted to try and see what it would look like if you had something like sorghum Sudan grass just as a monoculture out there, and then you add a legume to it in the hairy vetch. And so you can kind of see our control was the Sudan grass, and then the mix number 1 had the Sudan grass with about 25% of the mix being hairy vetch. And then you can see after the Sudan grass and the hairy vetch, we added the buckwheat into it. The third mix, you can see we put the radish net in it, to where eventually the fourth mix is kind of what you would see, or what most of these people that are putting in a cover crop, or what the NRCS is recommending. You've got multiple grasses, multiple legumes and that in there to fill that mix.
So to kind of update you, so this picture was taken, so we planted, like Mike said, in May 14th. This picture was taken about June 26th. So it's almost about 45 days there. And so you can see the kind of growth we got here in Lewiston. You can kind of see some of the differences. The pictures are kind of hard to focus in. You can see a lot of the Sudan grass in there. You can see a little bit of buckwheat and a few other things going on. But when we look at the 45-day, we took a forage analysis. And so you can kind of see the different protein levels throughout. So our control was about 17% protein. And as we added those mixes, mix number 1 had the legumes. So we do see a little bit more protein, 18.2%. And then in mix 4, where we had that huge mix, just kind of a variety of different things, we see that there is larger amounts of protein available in the percentage there. And so just to kind of compare, if we look at what we saw in Kaysville, so again, remember in Lewiston, before we got these research plots to be able to use, it actually had already been fertilized in Lewiston. And so because of that, we do see that there were higher protein levels in Lewiston specifically. But in Kaysville, where we're going into kind of what had been weeds for about 15 to 20 years, we see that the protein levels are a little lower. There's some different values there overall. So just some good information to kind of keep in mind, especially through grazing and different practices on those warm season cover crops. Now, we carried this study all the way out into 80 days, and 80 days is when we took our yield. And as you can see from these pictures, Sudan grass, as well as some of the other cover crops, really, it kind of turned into a jungle. You can see it's taller than us. You can kind of see down in the corner on that drone picture where these plots were. And basically what we did with these plots to measure yield is you can kind of see in this picture here, you see that we had about a mower, a sickle bar mower that we went in about 20 feet with a 4-foot swath. And then we took all of the material from there and measured it in totes, just so we could get an idea of yield per acre and tons per acre. And so with that data, this is just the machine we used in different things. But with that data, we decided to separate our yield into 2 dry matter percentages. First of all, we did one yield at 70% moisture. That's to resemble silage, kind of what your silage yield would look like, as well as we did a yield at 12%, because that's more of a hay-based material. If farmers are choosing to go in and use this for, either one of those two. But as you can see with our yields, we see in Lewiston, one of the interesting things is as we go up, as we add those more ingredients into the cover crop mix, you see that we actually get higher yields at the end. That mix number 4, mix number 3 really did jump up in that yield. However, that wasn't true in all of our in all of our field studies. For instance, in Kaysville, we didn't see that. And in Ephraim, we didn't see that either. And so it's just kind of some things to point out that could have been due to the extra nutrition that was allowed to the cover crops in Lewiston. However, it might also just be where we were able to get the cover crops in. We actually tended, when we were out there, to see a little bit more of the variety in Lewiston compared to the other plots. The other plots had a lot more Sudan grass. So that's just something to consider there overall. But moving on, looking at the 80-day data for forage nutrition quality, I hope this gives you a good picture. I'm actually going to fly through this because I know we're short on time, but you can kind of see the different protein levels at each site. However, one of the big things we wanted to point out is the 45-day versus 80-day. And so we agree, and we didn't think about going cover crops, having them go all the way to 80 days. We didn't think that was a good idea. We just kind of did it to see yield and different things. But you can really see that the 45-day would probably be the most accurate point, or at least the most nutritious point, if you're using this for a grazing or forage endpoint. So Mike, I'll turn it back to you for a second.
Okay, so then fall time, or I guess late August is when we started looking at our cool season mix. It's something that you'll be establishing kind of after a wheat harvest or corn silage harvest. And what we started out with our control was our throughway mix. You can see wheat, barley, triticale, and that is our base. And then we added a winter pea into that mix for number 1. And then we added the radish and then our turnips. And then finally we got to that overall mix of several grasses, several brassicas and legumes in there for our mix number 4, similar to what we did with our warm season.
But with the cool season mixes, we, like Mike said, we planted on August 17th to kind of mimic going in right after a grain crop. This picture was taken on August 31st. You can see we're getting a pretty good representation of the different cover crops there. However, at September 30th, which would have been about 45 days, you can just see that this is the kind of crop we had. And this was awesome. This was a great turnout. We didn't actually measure yield at this point because we're measuring it in the spring of next year when we allow it to come up. But really, honestly, we didn't have frost for quite a while here in the valley. And so this crop actually grew for a long time before it finally died out.
I think to mention on that is the fact that, you would have had some happy cows coming home off of the range and turn them into a pasture like that. So one of the other things we decided to do is with a lot of these mixes, growers, can't really visualize what that millet is going to look like, what the Sudan grass, hairy vetch, some of those would look like. And so what we did is we took 18 different species that are typically recommended in some of these cover crops, and we planted them out in a single drill width. And so you can kind of see there at the top picture, that's one of the millets. I think that's the white millet right there with the one of the grass, the sorghum Sudan grass right behind it there. And then you can kind of see, we pulled up some of the radishes, some of the turnips in that, just to give them a visualization of what those plants look like.
And to go along with that, we also put in some mixes. We did a warm season 10-way mix, cool season 8-way mix, cool season 6-way mix. We did a bunch of different mixes so that farmers could actually see it. And you can see it in this drone picture, how as we go down, as we did a couple drill widths on each of these, you can see the differences as you kind of go through the different mixes and different things. We took some data on them. These weren't replicated plots, so this data isn't really necessarily on the research-based side, but we did want to just get some numbers to see what kind of things we were seeing here. You can see the 45-day compared to 80-day values, and you can see that there were warm season mixes here as well as cool season. We also see in the yields the 70% moisture and the 12% moisture again. So you can kind of see these numbers here just as a demonstration purpose overall. To see kind of what we had. And just to wrap up, we know we had to hurry through this. We just want to thank, we had a lot of people working on this project. We want to thank everyone who was involved.
I think to point out right there, that cover crop mix that we had, oh, Jake, you pulled it down on me. The diversity that we saw right there, that was really cool from a researcher standpoint to go out into that field right there and look, you can see the sunflower, you can see the oats, you can see the Phacelia, you can see some buckwheat there. Just a really nice blend of different mixes right there. So a really cool photo.
Yeah, and you can see over here, this is more of a warm season. This also shows the variety. I mean, we got mustard, buckwheat. You can see kind of some of the turnip and radish down low. And that's one thing we did see is that when these are put together, a lot of times we do see a pretty good synergistic effect between the different mixes being combined.
So with that, I think we'll wrap up our tour for today. Really appreciate all the presenters taking time. I know it's a lot of work to get these videos put together and, do all this stuff, and really appreciate all the work. It was very interesting, and I learned a lot.